Hello and welcome, everyone. Let me know if you can see and hear me and see this puzzle that we're about to solve. Make sure everything is good before I dive too deep into what we're doing. Looks lovely. Excellent, excellent. All right, so as has become the tradition, we're going to start this Wednesday, or Thursday if you're in different parts of the world than I am, with a Zeta tutorial. And so this is going to be actually the most basic of the ones I've done so far, because I realize every time I sit down to do it, I start explaining how Sudoku notation works. And so I think it would be really helpful to have a video where I go over how Sudoku notation works, explain why it works that way, the basic things that fall out of it, and then talk about applying it to some of the constraints that are basically all notation. So we're going to talk about Snyder notation, which if you don't know what it is, I'm going to say what it is. And then we're going to talk about applying it to classics, to Sudoku X, to anti-knight, to anti-king, and to non-consecutive. So we're going to do a bunch of examples of applying this basic idea of Sudoku notation and how it works. It's part of a series. Again, this is the third part I'm doing, although probably the first part you should be watching. So this will probably be first on the playlist when there's a playlist someday. But anyway, I wanted to start by sort of thinking about what the rules of Sudoku are telling us. And so the rules of Sudoku all pertain to three things. They pertain to rows, columns, and boxes. And what they tell us is that in each row, column, and box, I need to have the numbers 1 through 9 appear once each. But for purposes of actually thinking about Sudoku deductions, it's actually, I think, very helpful to break that appear exactly once each into two parts. One part is the every digit appears at least once piece, and the other part is the every digit appears at most once piece. Or to put it a different way, in every cell, I need to put a digit. I don't know what digit it is, but it needs to be one of the digits from 1 through 9. I need to put it in the cell. But then in every row, column, and box, I need to find a place to put the digit 3. One of these cells has to be a 3. One of these cells has to be a 3, and so on. Now, the trick when you start Sudoku and you learn those rules is you start doing the puzzles, and then you have to figure out, how am I going to write down the things that I see? Because the things you want to note are quite different depending on which side of those things that you see. So, for example, you might see that, oh, the 3 in this box goes in one of two places, and that tells me something, so I want to write that down. But on the other hand, you might also see that, oh, this cell can only contain the digits 2 or 3, and so you want to write that down. And so the way that Sudoku notation is usually done online, and possibly in paper, although I admit I do not solve Sudoku puzzles in paper, accounts for these two different types of deductions by using two completely different types of notation. And so those types of notation are center marks and corner marks. Collectively, the use of center marks and corner marks in this way is called Snyder notation, after, I believe, Snyder was the person who developed this. Because again, this is a very non-obvious thing to do that, well, I didn't come up with, and people did not come up with for a long time. But it is sort of the canonically correct way to notate things in Sudoku puzzles. Okay. And so I want to explain what both of these pencil marks mean, and then I want to explain how to use them, and then we're going to use them in a bunch of puzzles. Okay. So center marks tell you what digits a cell could be. So if I mark this with a 2 or a 3, that's the way I should read this center mark 2, 3, is this cell is a 2 or a 3. And so if later in the solve I put a 3 here, what does that tell me? Well, it tells me I can look up here and say, well, this cell was a 2 or a 3, but now it's not a 3, so it's a 2, and I can fill in the 2. That's how center marks work. Corner marks pertain to the specific question, where does this digit go in this box? And so if I have a corner mark in these two places of a 4, that's telling me that one of these two cells is a 4. If, as we'll see later, I have a third corner marked 4, that's telling me one of these 3 cells is a 4. So we have that. Okay. So if, again, later in the solve, I were to put a 4 here somehow, that would tell me, well, this cell can't be a 4, and this cell can't be a 4, and now this is the only cell in the box that can be a 4, so this cell would be a 4. Okay. Now, if you're astute, you will notice that there's something really, really off and weird about corner marks, which is that Sudoku is completely symmetric across boxes, rows, and columns in terms of the rules. But for corner marks, I called out specifically boxes. So, namely, if I knew, for example, let me just get rid of all these digits. If I knew, for example, that the 4 in this row was in one of these two cells. In fact, actually, let me get rid of all the color as well. Oops. If I knew the 4 in row 4 was in one of these two cells, I would not do that. At least not typically. Now, that's just a weirdness of what the most common use case is of this notation. So I don't have a particularly nice way in Snyder notation to mark if I know a digit is restricted to 2 cells in a row or in a column, only if it's restricted to 2 or 3 places in a box. Okay. Now, you'll see often... Hey, welcome, Samantha. Glad to see you back after you joined us. Sorry, I realize I'm not supposed to talk to chat while I'm doing the teaching thing. I'll learn eventually. Now, there's sort of a cheaty way that you'll often see me do this, and you'll see some other people do this too, which is to take advantage of the color to say that, hey, if I'm going to make a strange corner mark, like 4 is in one of these two places in the row, I'll just put a yellow flag here to tell me, hey, this corner mark applies to the row and not to the box. Anyway, that is a thing you will oft see. All right. So, what else? So, just to make this, I think, super clear, I think it's helpful to think about what happens if you know absolutely nothing. And so, if you know absolutely nothing, then you could theoretically start a puzzle by center marking 1, 2, 3, 4, 5, 6, 7, 8, 9 in every single cell. I know that each of these cells contains the digits 1 through 9, and that's sort of my base case for the center marks. Now, with corner marks, you could say, I know the 1 in this box is in one of these 9 cells. Or I know the 2 in this box is in one of these 3 cells. Or the 3, or whatever. And so technically you could start by doing this too. So you could do that. I don't necessarily recommend it. Probably not super helpful. But that's sort of the basic starting point of this. Okay. Now, these deductions that you get out of this have specific names. And really almost every deduction that you're going to get in a Sudoku puzzle is really one of two things. That is, it's either a naked single or a hidden single. Almost every digit you place is going to be one of these two things. Perhaps every digit you place is going to be them if you take it literally enough. Okay. And so the way this works is if I pick some cell like this cell, I could write in what digits this cell can be in the center. And so you'll hear me do this a lot out loud. I'll start, okay, can this be a 1? No. There's a 1 in the box. Can it be a 2, a 3, a 4? Can't be any of those. Can it be a 5? Sure. Can it be a 6? Sure. Can it be a 7? No. Can it be an 8? No. Could it be a 9? Yes, it could. And so when I go to sort of center mark this box, that's what I get. And so it's usually not very useful, but you could just start by center marking every cell in a grid. that would not be a very good idea, probably, but you can do that. Now, I will plug here an app that I think really helped me when I was learning Sudoku, which is called Good Sudoku. It's on Apple and Steam and a few other places. And what it does is it gives you classic puzzles, so just puzzles like we're about to do with just some digits dumped on the grid. But it automatically center marks every single cell for you so that you don't have to think about what cells to center mark. It just does them all for you, and it keeps them updated for you so that you can just focus on the deductions that you get out of this. And so I think that's a really good way to learn all of the techniques we're going to talk about today, as well as a few more techniques that goes beyond that. And I should warn you, for the very, very advanced people, if you want to practice with it. I mean, you can do a classic Sudoku in about 2 minutes with Good Sudoku because it does so much automatically for you, but it gets you very good at spotting things. I'll warn you, it does eventually start training you to use uniqueness, which I'm not going to talk about today, but just be warned. All right. Now, this was, in fact, not the useful cell to center mark here. This is the useful cell to center mark here. Because if I look, I can ask myself, can this be a 1, 2, 3, 4? No. Can it be a 5 or a 6? No. Can it be a 7 or an 8? No. And so actually the only digit this cell can be is a 9. But as soon as you see the only center marked digit in a cell, then this cell, I know what digit goes here. Okay, because again, the center mark is every possible digit that could go in this cell. And so every digit that can possibly go in the cell is a 9, so therefore the cell is a 9. Okay. That is what is called a naked single. And so any cell that once you center mark it, you get only one digit, that's what's called a naked single. And so often you'll see people, when they're solving, they'll say they've spotted a naked single, or you'll see people in chat talking about it, etc. Okay, and then of course, if you're keeping track, you should then carefully update your pencil marks so that now that that's a 9, this can't be a 9 either. Okay, so that is how naked singles work. Now, I emphasize this because it often gets confusing, because the other way is called a hidden single, and it feels logically very similar, but is meaning something quite different, and I think the distinction is worth learning. So if I pencil mark every cell in this box, here's how it goes. And then these ones can't be 3, and I get this gigantic mess. There are no naked singles at all in this puzzle. As it currently, I mean, this isn't really a puzzle, just in the digits that I have placed here. But actually, I can ask the question the other way around. So I can, instead of asking the question, what digits can these things be? If I ask the question, where does the 3 go in this box? Then actually I notice none of these digits can be 3. And so this digit is a 3. This is a hidden 3 for the box. This is the only place in the box that a 3 can go. Okay. Now, quite often in the case that it's a box specifically, rather than saying it's a hidden single, what you'll hear people say specifically is, oh, this digit is placed by Sudoku. Okay. The particularly insidious hidden singles are the ones that occur in columns or rows, usually in variant Sudoku, where there's a bunch of different factors that sort of conflict together to mean that the only place in a row a 2 can go is here. But if the only place in the row a 2 can go is there, that's a 2. That's all you need to know. All right. And so that's really the 2 types of deduction you hope to get out of these notations. It's how we mark them. And I'm going to do some puzzles that sort of show off these kinds of deductions. Oh, I'm missing a 6. Thank you. Oops. It's probably, yes, I missed a digit. There should be 6s marked here. I think that only makes things look worse, but there we go. All right. So that said, let's start with this gas classic by Philip Newman, and let's practice doing these things and looking at the kinds of deductions that we get out of them. All right. So I should, by the way, again, mention the gas puzzles, which are these puzzles that are posted every day to the Cracking the Cryptic Discord that are meant to be fairly straightforward, easy puzzles. So if you're looking for puzzles to practice any of the stuff we talk about on the stream on, going and doing the gas puzzles is great. There's over a year of them, so there's probably 400 or more gas puzzles now that you could do. I usually pull out a couple of them to demonstrate the things that I want to demonstrate. All right. So when I look at this grid, the first thing I notice, well, I notice two things. One is this column, and one is this row. And what I notice is there's a whole bunch of digits already filled in this column and row. And so what that means is I'm going to be immediately inclined to fill in these cells for what they could be. That is, I'm going to be inclined to center mark them. Now, usually my rule is if there's 5 digits in a row, 5 digits in a column, or 5 digits in a box, then unless I'm actively doing something else, I'm going to start center marking it. So in this case, there's 6, so I'm just going to start center marking this. And so the way I do this, and you'll hear me do this out loud, is I'll just count 1. There's a 1. We need a 2. We don't, or we have a 3, we have a 4, we have a 5, we have a 6. We need a 7. We've got an 8, and we need a 9. And so these digits are from 2, 7, 9. Now, I should update that, because actually there's a 9 in this box already. So this digit can't be a 9. And there's a 9 in this box already. So this digit can't be a 9. And now, that actually tells us something in this row, which is that actually within this row, there's only one place for the 9, so namely this digit has to be the 9. Okay. And so there's actually 2 different ways of seeing this, and you'll see this get juggled around quite a bit. So the way I just did it is to say, so this is the only place that a 9 can go, so this is a 9. In other words, I saw this as a hidden single. But that's not the only way to see this. There's a different way to see this that turns this cell into a naked single instead, which is to look at these 2 cells. So I'm going to get rid of the rest of my coloring. And so I'm going to look at these 2 cells. And so these 2 cells each are center marked with a 2 and a 7. And so these 2 cells form what is usually called a pair. And it's a pair because, if I think about it, what digits are in these 2 cells? Well, the digits that are in these 2 cells are a 2 and a 7. I don't know what order, but there's 2 possible universes. There's the universe where this digit's a 2, in which case this digit's a 7, in which case these 2 cells are a 2 or a 2 and a 7. Or this digit's a 7, in which case this digit's a 2, and in which case these 2 digits are a 2 and a 7. I have to put some digit in these 2 cells. They can't be the same digit, and the only options are 2 and 7. So these 2 are always going to be the digits 2 and 7 in some order. But that means that in this row, there's already a 2 and a 7. So this cell can't be a 2 or a 7. So that rules 2 and 7 out as candidates from this cell, meaning that the only candidate is a 9, which makes this a naked single. Okay. Now, if you're listening to this and you think, isn't that kind of saying the same thing twice? Yes, it is absolutely kind of saying the same thing twice. But in slightly different ways that you end up seeing differently. So I think, for example, pairs often jump out at you a lot better, or at least maybe I should say pairs often jump out at me a lot more clearly than hiddens do. Hiddens are usually something I only see if I sort of have to take a breath and take a pause and stare at things. Whereas sort of a 2-7 pair popping up, I will notice some percentage of the time on my own. Okay, so let's mark the column as well. So we need a 1, we've got a 2, we need a 3, we've got a 4 and a 5 and a 6 and a 7, we need an 8, and we've got a 9. Okay, so let's update. This can't be an 8. This can't be an 8 either. So now we have our 1-3 pair in the column. And so that being a 1-3 pair in the column means that this digit's an 8. Or alternatively, you ask where does 8 go in this column, and you get that this digit's an 8. Or if you weren't doing any of this and you are just used to doing newspaper Sudoku, you might think of this as just seeing these two 8s and visually seeing these two 8s as forcing an 8 here. Again, 6 of one, half dozen of the other, whatever way you want to think about it is fine. Okay. So that gives me more cells I can fill in. Because again, my usual rule is I'll fill it in if there are 4 or fewer options. So now in this box, I have 5 digits, so there are 4 leftovers. So I've got a 1, I need a 2, I've got a 3, a 4, a 5, I need a 6, 7, 8, I've got a 9. I can see that these digits aren't 8. I can see that these digits aren't 6. I can see that these digits aren't 2. Let's see, did I miss anything? Maybe not immediately. So let's look over at this box where I have the same thing going on. I've got a 1 and a 2. I need a 3, 4, 5. I've got a 6, 7, 8. And I need a 9. So I see that these aren't a 3. These are from 4, 5, 9. These aren't a 5. These are from 3, 4, 9. And, well, that is, I think, all that I get out of that. All right. So let's see. What else should we mark? Let's see. So just to give some examples of corner marking, and here's the sort of thing that you'll often do when you're solving, especially if you're just trying to make the end part fast. I can ask myself where 1 goes in this box. And so if I look at the row and the column, I see 1's ruled out. So actually, I know that 1 is in one of these 2 places. So that is how corner marking works, is that one of these 2 is a 1. All right. And so you can continue sort of hunting. And so often people do it digit by digit. So they'll say things like, okay, where does 1 go in this box? 1 in this box goes in one of these 2 places. And so where does 1 go? Yeah, maybe we've run out of places for 1s. We could ask about 2s in this box. 2 in this box goes in one of these 2 places. And so you're just looking for, and you can, by the way, in the Cracking the Cryptic app, you can just double click a digit, and that will give you a pretty good idea where the nice versions of that digit are. So you can ask about 3s. 3 in this box goes down here somewhere. 3 over there goes lots of places. Again, I'm usually only going to mark if there's 2 places for a digit to go. So in this case, 3 goes in one of these 2 places. Okay. Now, this is a perfect example of why doing this is useful. Because these 3s collectively push 3 into one of these 2 cells. And that tells me that within this box, the 3 is in one of these 2 cells. Which actually tells me that the 3 in this column is in this box. So whenever I get sort of a digit pencil marked into 2 cells that align like this, I'm actually ruling 3 out of this column as well. So actually that gives me an extra pencil mark, which is that I can pencil mark that the 3 over here goes in one of these 2 places. Okay, but that's about all I seem to be able to get out of 3s. What about 4s? I guess I know that one of these 2 is a 4. What about 5s? And that's great, because now look at box 4 with respect to 5s. 5s with respect to box 4 are pushed into one of these 2 cells, except not that one. So actually, this is a 5. And now here is where you have to actually, if you're going to use the pencil marks, you have to learn the next step. The next step is to actually use your pencil marks. Because these 3s in the corner, remember, mean one of these 2 cells is a 3. As soon as I place a 5 here, I've learned that this one's not a 3. And so this one had better be a 3. I can get rid of these colors because they were just there for that. And now that 3 looks back over here and tells me that this cell that I knew was a 1 or a 3 is a 1. is a 1. Now that 1 looks down here and tells me that's a 3. But I also had corner marked 1s in this box, so that's a 1. And now we have a whole bunch of stuff sort of firing off all at once. Okay. Now that 3 looks over here. That's not a 3. And so now by our corner marked 3s, that's a 3. And so your markings, even if they're not immediately useful, if you see them, they'll often sort of save you time later in the solve. Okay, so I'm seeing now that we have 6 digits in this box, so let's fill in those. We need a 1 and a 2. We've got a 3, 4, 5, 6. We need a 7, and we've got an 8 and a 9. This one's not a 1. Again, we see we have this 2-7 pair in the box. So these 2 digits are the 2 and the 7. So this can be neither a 2 nor a 7. So therefore it's a 1. This box, same deal. We've got 1, 2, 3, 4. We need a 5, 6. We've got a 7 and 8. And we need a 9. This is just neither 6 nor 9. So it is a 5. Those are the only... This is a naked single again. These are not 5. I don't think I can sort this out yet. So I'm going to look at this row. This row has 1, 2, 3. We need a 4. We've got a 5 and a 6. We need a 7 and an 8. And we've got a 9. Okay, and so this is not an 8. This looks like it can be anything as best I can tell. This looks like it can be anything as best I can tell. What about... So let's look at this row now. So this row doesn't immediately look like it's eligible to be pencil marked by my pencil mark rules, because I only have 5 digits in it. Or sorry, because I only have 3 digits in it. But I actually have 5 digits in this row, because again, these two are a 6-9 pair. So actually, I know these 5 digits are a 1, 3, 4, 6, and 9. And so these outer digits are a 2, 5, 7, and 8. They can't be 6 or 9 because of the pair. Okay. So this digit can't be an 8. This digit can't be a 7 or an 8 or a 5. So this is a naked single. So it's a 2. So this is not a 2. These aren't 2. Let's poke our head back over here and see if we get any other eliminations. I see this isn't a 5. It's a 7 or an 8. And so now we get another interesting can't be it. So now we get another interesting thing, which is that if you look at row 7, column 2 can be an 8. Oh. What? Oh, no. Sorry. This can't be a 5 or a 7. I just erased it. Never mind. Ignore my claims. This can be an 8. I don't know where I got the 8 from. Who knows? Let's see. Well, we can still simplify that. That can't be a 5. Well, that's sad. Okay. Where else are we going to look for our next bit of joy? How about this column? So this column now is missing a 1 and a 2. It's got a 3, 4, 5. It's missing a 6. It's got a 7. It's missing an 8. So this cell really is a naked single now, because it is not 1, 2, or 8. I stand by it this time. That's a 6. So this isn't a 6. That's not a 6. This cell is not a 2, because there's a 2 in the row. Or alternatively, because I've pencil marked the 2 in the box, whichever way you want to think about it. This cell's not an 8. Which gives me not a whole lot useful. So let's continue. Yes, I would never misscan, assuredly not. This row, let's fill in. We've got a 1, we need a 2, a 3, we've got a 4, a 5, we need a 6, a 7, we've got an 8 and a 9. This is not 2 or 7, it is 3 or 6. This is, who knows? Yeah, I think we do not know what this is. Okay. So What else can we do? So another thing you can do is you can go back. So we went over all the digits to start with. So we can sort of go back and look at, okay, has anything new happened with regards to ones, for example? Or has anything new happened with regards to twos? Or threes? And so, do that. What about fours? Or fives? And so you can sort of quickly scan through these things and look for which of these is going to be useful. So sixes, actually, I realized I never got to sixes before. Because this six is... Oh, I guess, no, sorry. This six hasn't been here the whole time. But this 6 is placed because I have aligning 6s looking at this box. So none of those are 6. That's not 6. This is the only place for a 6. As soon as that's a 6, that's a 1. And so now I've got more 1s placed. So now I know the 1 over here is in one of these two cells. I'm not going to mark that. I'll mark it. Why not? Let's see, this column I can now mark, so I need a 2, I've got a 3, a 4, a 5, a 6, I need a 7 and an 8. Conveniently, this cell can't be a 7 or 8, so this is a 2. This is not a 2, that's not a 2, this isn't a 2 because it's in the same box. Quick scan to see if this sees a 7 or 8, quick scan to see if this sees a 7 or an 8, this sees an 8, so that's a 7 and an 8. Now that's going to do a whole lot. Neither of those can be 8, but that 8 also looks across here and gives me a 2, which then gives me a 1 down there. This is not a 2, because there's a 2 in the box. This 1 looks up and makes this cell an 8, which makes this cell a 1, because remember my corner marks placed 1 in one of these two cells. That one's not a 1, so this one is a 1. But that 1's now dislodged my 3 corner mark. So now this isn't a 3, so this is a 3, which Simon would give a lovely song about 3 in the corner, losing its religion or something of that nature. And so now we're almost done, because now suddenly the digits have sort of proliferated themselves into the grid. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 is what's left in the row. This is not a 5. Do I know absolutely nothing about these? I might know absolutely nothing about these. These are, it looks like 3, this looks like it can be 4 or 9 only. 3, 4, 9 for the row, but there's a 3 in the box. But now we have our first appearance of a triple, which is suspiciously like a pair, except with 3 things instead. Which is that all of these cells can only be from the digits 4, 5, and 9. And so these 3 cells must ultimately be filled with the digits 4, 5, and 9. And so when I ask what this digit can be, it can't be a 1, 2, or 3, but it also can't be a 4 or 5 either, because I know that one of these digits is the 4 and one of them is the 5. It's not a 6 or a 7, and it's not a 9. So the only digit this can be is 8. This actually becomes a naked single on account of this triple here. And so now that 8 looks down there. Now, once that 8 knocks that corner mark out here, these two cells are now a 6, 7 pair. Again, that just means that these digits contain a 6 and a 7. And that does a few things. One is it means this digit can't be a 7, because the 7 in this box is in one of the yellow cells, so that's a 2. And this is an 8, because the 2 in the box is gone and the 7 in the box is gone. It also means this digit can't be a 7, because the 7 in the column is one of the 2 yellow cells. And so that's a 4. And so that's going to do immense damage. So that 4 looks over here, makes that a 7, that a 5, that an 8, that a 2, that a 7. That 7 looks back over here and gives me the 6 and the 7. I can de-yellow these. I have put a 4 into here. Let's see. Let's fill in this row. Actually, sorry. Let's fill in these two cells first. What are these? We've got 1, 2, 3. We need a 4. to go in one of these cells. And we need a 5. No, we don't need a 5, sorry. We need a 6. And then we got the 7, 8, 9. So these are a 4 and a 6. And I know the order because of this 6. So that's a 4 and that's a 6. That 4 bounces up there to make that a 9, making that a 5 and a 4 and a 9. So these aren't 9 anymore. These are a 3 and a 4, so these certainly aren't 4. These digits I can actually do just by the column. So anytime you have 8 digits filled in a row, column, or box, the remaining digit has to be a naked single. So this one's not the 2 anymore, so that one's the 2, and now I only have to do this, and so I can count 1, 2, 3, this one's a 4. This row's pencil marks have been horribly neglected, so this is not a 7 or a 2, it is also a 3 or a 6. These digits, oh sorry, this one is a 7, let's just do that, that's probably easier, because of the row, and then these digits are a 2 and a 4. 5, 6, 7, 8, 9. So these are a 2 and a 4. The 2 there tells me that this one's the 4 and that one's the 2. Not the 0. Not the 0. The 2. The 4 looks up there and gives me a 3 and a 4. The 3 looks down and gives me a 6 and a 3. The 6 looks down and gives me a 9 and a 6. The 9 looks up and gives me a 5 and a 9, which I put in the wrong place. It does not help if you put it in the wrong place. The 5 over there gives me a 7. 1, 2, 3, 4. That's a 5. 1, 2, 3, 4, 5, 6, 7, 8. And that's a 9. And then the puzzle is done. So that's what a classic puzzle with these sorts, or with this sort of notation looks like. So we're going to do a few more classics, and then I'm going to show you some of the weirder types of puzzle that also are really just all about this notation. I should say, by the way, specifically, there are many techniques for solving classic Sudoku and others that are not just finding these, but for example, for most newspaper puzzles, you'll be able to get by with just these techniques, but you'll learn others if you hang around here. Okay. Let's do another classic. So this one is by dumediat, frequent participant in the chat. And so, yeah, newspaper, you often don't even need to pencil in the digits. That's true. Alrighty. So, yeah, by the way, the gas puzzles, a lot of people like to speed run the gas puzzles, and so they'll give you sort of a target time. Hint, if you want to meet the target time, don't patiently explain everything you're doing. But that's okay. So I'm looking for cells that can only be 4 or fewer things. Yeah, I'm specifically avoiding multi-row stuff in this tutorial. But yeah, there's plenty of more stuff to do Sudoku. Okay. So these cells I'm noticing are somewhat restricted. And that's because they see 5 different... These two cells both see all 5 of these digits. So I'm going to just start by penciling in these digits. And so they are not 1, they could be 2, 3, 4, not 5, 6, they could be 7, not 8 or 9. This one's not 4 or 7. This one seems to be able to be anything. These cells are likewise restricted. These cells see these 5 digits. Note, part of the reason why I'm homing in on these is these are 5 distinct digits. If there were a repeat digit, suddenly all the excitement would go out. So if I looked at these 3 digits, for example, oh, I should look at, well, I'll look at those in a minute. But the fact that the 6 repeats makes it a little bit less exciting. Okay, so these are from 2, 3, 4, 5, 6, 7, 8. This one's not a 2 or a 7. This one looks like it can be anything. What about these? Let's... I was going to poo-poo those, but actually these are somewhat restricted because they see all of these digits, which includes a 6 twice. So the 6 twice is a little bit sad, but it does include 5 digits. So these be 1, no, but they could be 2, but not 3, 4. They could be 5, but not 6. And they could be 7 or 8. And so then I look down the column and see, okay, they're not, this one's not 7 or 8. This one's not 2. This one doesn't have anything in its column. And so I scan briefly to see if I see anything that looks interesting there. I regret to report I do not. So let's look over here at these cells now. And so in each of these, I'm just highlighting groups of cells that see 5 or more digits in common so that I can double pencil mark them. So this sees, or sorry, this does not see 1, 2, 3. It sees 4, 5, 6. It doesn't see 7, and then they see 8 and 9. So I could look here and say this is not a 7. This is not a 2. And so I can sort of bounce around looking at that. This doesn't appear to me getting me anywhere super quickly. So let's switch perspectives. And instead of looking at cells, let's look at digits. So we have ones here. And so I can notice some things about ones. So let's look at ones in box 5. 1 in box 5 can only go in one of these two places. I don't know why. I'm inclined always to start looking at cells instead of looking at digits. It's probably the wrong way to go, if I'm being completely honest. But these two center marked ones, again, tell me that the 1 in column 6 is captured by box 5. So the 1 in this box is in one of these two places. Let's see, I can do a similar thing with the 1 down here. Don't see anything else immediately from that. 2 makes its way into 3 places in this box. There's not that many boxes that 2s look at. Yeah, I don't think it's going to be 2s. 3s. Well, the 3 here is in this column, but that's not exciting. 4s. Well, I can corner mark a 4 in one of these two cells. Do here. 5s? Well, there's only one 5, so probably 5 is not great. 6. Well, the 6 goes up here. About down here. 6 goes down here somewhere. 7. The 7, we get a digit. The 7 is placed in box, this one, in box 6. Because the 7 in these two rows rules it out, and the 7 in this column rules it out. That's a 7. And so now we can look at 7 some more and see if that gives us more joy with 7s. It tells me that one of these two is a 7. Let's see, the 7 over here, right? The 7 over in this box is in one of these two cells by Sudoku, if I did that right. Yep, the 7 is in one of those two cells. And so that actually gets us an elimination, because it tells me the 7 in this column has to be down here. So this digit's not a 7 anymore. This is a 2, 5, or 8. Now, what about, so we did 7s. What about 8s? So we've got some don't have many 8s. We do have 2 8s that put 8 in the corner down here in one of these two cells. But that's it. What about 9s? Well, that's helpful. So the 9s here, the 9 here is placed here. Now, I want to point out something that someone in chat noted much earlier, which is a different way that you could see this digit had to be 9, which is that these digits are, in fact, a quintuple. And so these digits, all of the center marks here come from 2, 4, 5, 7, and 8. Which, by the same logic of pairs and triples, means that these digits actually are collectively exactly the appearances of the digits 2, 5, 4, 7, and 8 for the row. So this digit is not a 1, 3, 6, 2, 4, 5, 7, or an 8. And so this digit's a 9. Okay. That's probably the not the easier way to go about it, but it works equally well. And so if you're sort of on the lookout for those kinds of things, often it'll help you sort of make up for missing other things that maybe you should have seen, arguably. Let's see. I see that the 9 in that box goes there. Let's see. The 9 in this box goes in one of these two cells. So now the 9 in this row is down here. So the 9 here is going in one of those two cells. And so now, actually, we can do something really fancy, which is to ask where 9 goes in this row. The way I saw that is that I noticed that the holes in this row lined up suspiciously well with the locations of the 9s. And so in particular, where 9 in row 5 goes, there's only one place it can possibly go. Namely, it can only go here because 9s rule it out of every other place. Well, sorry, 9s plus given digits rule it out of every other place. So therefore, this is a 9, and then by our center marks, this is a 1. And now once that's a 1, these ones I rescan and look over, and they place a 1 there. And then I rescan and look over, and now 1 is pencil marked here. And that's going to do a few things. But one thing it does that I want to really note is that I have both 1 and 9 corner marked into these two cells. So in other words, the 1 in this box goes in one of these two cells, and the 9 in this box goes in one of these two cells. So what are these two cells? Well, they have to be 1 and 9, because otherwise I'm not putting 1 or I'm not putting 9 in here. And so what happens here is if you collect enough corner marks together, they convert to center marks. And so because these two cells are both corner marked 1, 9, they actually switch over to center mark 1, 9, which does a lot of things. So one thing it does is it kicks out the corner marked 6. This digit can't be a 6. If this digit was a 6, it would be impossible to put both 1 and 9 in this box. So this digit's not a 6. And of course, as soon as that digit's not a 6, this digit's a 6. But now, I kicked out the wrong corner mark. But I usually just remove the corner marks when I switch them to center marks. This 1 here, it rules 1 out of that cell, which places a 1 here. And so we can sort of scan our 1s. Yeah, I guess we've got sort of a 1 corner mark going on up here, but it doesn't tell me very much. Okay, let's look at 6s now, though, because we placed a 6, and we did not have many 6s before. So one of these two digits is a 6. Let's see. Okay, let's pencil mark this row. This row seems ripe for pencil marking. So we've got 1, 2, we need a 3, we've got a 4, we need a 5, we've got a 6 and a 7, we need an 8, and we've got a 9. So these are only 3, 5, and 8. And so that lets me spot that this cell can be neither 3 nor 5, so it is an 8. So these aren't 8. So these cells have become a 3-5 pair. I'll look at that in a second, but I want to pencil mark the rest of this box. I missed a possibility in row 3, column 2. Oh, these 1 corner marks are invalid. Thank you. Sorry, when I was looking at where 1s could go, I missed that a 1 could go here. So I could corner mark a 1 in 3 cells. I usually don't. You'll probably see me corner mark a cell in 3 cells later when I'm doing an anti-knight puzzle, but usually I will not do that unless I am really desperate. But yes, chat is correct. I did miss corner mark the 1 because I missed a place where 1 could go. Okay, this box only has 3 things left in it. Those things are a 4, a 5, and a 6. That one's not a 5. This concludes the list of things Zeta knows about what digit it is. What about these? Okay, well, that one's not an 8. Let's fill that in. This column needs a 2 and a 4. It's got a 5. It needs a 6 and a 7, and it's got an 8 and a 9. That one's not a 2. That one's not a 7. Okay. What about this box, where, again, these two are 3 and 5, because they're a 3-5 pair, so I can mark the other 4 cells without feeling too guilty about it. 2, 3, 4, 5, 6, 7, 8, 9 is what appears to be left. I know that's not a 9, and that's not a 9. I also know that's not an 8 because of the column. This isn't a 6 because of the column. Not really how I get. It's very sad. Okay. So let's look at. So we looked at 1s. If we looked at 2s recently, we really still don't know anything about 2s. 3s, we still know very little. 4s. 4 is now good in box 3, because if you sweep those, then 4 actually only goes here. Dislodging a 7 pencil mark, which means that's a 7. And now meaning that this box is really just a triple, so we can fill that in. So we've got 1, we need a 2 and a 3, we've got a 4, we need a 5, we've got a 6 and 7, 8, and 9. So these are just 2, 3, 5. Which seems to give us minimal help, in fact. What about these 2 cells? Maybe that'll be helpful. We need a 2 and a 3. We've got a 4. We need a 5. We've got a 6 and a 7. We need an 8, and we've got a 9. Okay, so this isn't 2 or 8. It is 3 or 5. Aha! And so that gives me a 3-5 pair in the column, which tells me that no other cell in the column can be 3 or 5. So this isn't 3 or 5. That is 2 or 8. Get rid of that. It's also a 3-5 pair in the box, but that's not exciting. Let's see. Anything else going on over there? I'm just scanning to see if there's any pencil marks that I have not updated. Yes, 4. Now 4, where does 4 go in box 9? 4 in box 9 now only goes here. Just by Sudoku. And so that's a 4, which now by our pencil marks means that's a 6, which knocks 6 out of these cells. And now, in particular, it places 6 in this box. Now this is the only place 6 can go. Or if you want to think about it, this is a 2, 8, 9 triple. I don't know. For whatever reason, this one I saw that way. I saw that this 6 goes here, which makes that a 4, which rules 4 out of this 4 corner mark. Placing a 4 there means these aren't 4. Now this row has effectively 6 digits filled into it. So these are the leftovers. These are 2, 8, and 9, the digits that do not yet appear in the row. So this isn't an 8, this isn't a 2. We've got that all good. these cells over here, let's go ahead and pencil mark. So they're from 2, 3, not 4, 5, not 6, 7, and 8. I know this one's not an 8. Disappointing. Is this one even more disappointing? This one's even more disappointing, isn't it? Well, that's just very sad. I am hurt by these pencil marks. Okay. So amusingly, these cells are quite unrestricted. Let's see. Okay, so what about 7s? Is there, as of yet, undone work with 7s? Doesn't look like it to me. What about 8s? So we've got more 8s now. Not quite. 9s? We've got a bunch of 9s. Aha! This 9, when I placed it, dislodged a 9 pencil mark, and I didn't notice. Placed a 9 there. I don't know that it did a whole lot, but hey, it's enough for me to pencil mark this row, so I'll do that. We've got a 1 and a 2. We need a 3, 4, 5. We've got a 6. We need a 7. We've got an 8 and a 9. So this is not 4 for multiple reasons. This isn't 4, and that's not 4, by the way, because I put a 4 in the column, and then that's not 4 either. I put a 4 in the column and then never updated it. So that is a good thing to notice. This isn't 3, because there's a 3 in the column. Did I do any more missing updating that was obvious? Ah, yes. I also missed that this 6 here rules out 6 from this, and so that makes this much better. So that's the 7. This is why we have these conversations. That being the 7 does a few things. It dislodges a 7 pencil mark, which places a 7. It also puts a 3, 5 pair in this row. And so this is a 4. This cell now, to finish this box, it also has to be a 3 or a 5. Those are the only options left. So that's a 3, 5 pair in the column, means that's not a 5. Now to finish this column, this has to be a 2 or an 8. And now in this box, I see I have a 2, 8, 9 triple. And so these digits are not 2, 8, 9. They're not 1 either. So they are 3, 5. Oh, they are 3, 5. So we have that. Trying to decide if I know where 3 goes down here. I fear I do not know where 3 goes down here. Let's see. Pencil marks, pencil marks. Yeah, I'm not going to get my last 9 until I know what's going on over here. Still not doing much with 2s. Still not doing much with 1s. Oh, this column is ridiculous. So here's a helpful thing if you're bad at scanning like I am and you frequently miss things. If there are ever only 2 cells left in a column, as there are here, and those 2 cells are not a pair, e.g. they're not the same digit, or the same pair of digits, that means you have missed updating your pencil marks. And so as soon as I see that this is a 2, 7 and a 2, 6, I don't know what's wrong, but I know something is wrong. And in this case, the something that's wrong is that this is a 7. So this should not be a 7. This should just be a 2, and this should be a 6. And so that's an 8, and that's a 2. And so now that's a 9 and an 8. Now that's a 2, dislodging a 9, so making that a 9 and an 8, and a 2. That 2 makes that a 3. Makes these a 2, 5 pair. That 8 looks over and makes that a 4. This isn't an 8 anymore. I have a similar thing going on here where these are not a pair, and so I know I need to find something. So that's a 5 and a 7. So that 5 makes that a 3 and a 5. This is not a 3 anymore. This is not a 7 anymore. At the very least, I can say that much. This row, let's go ahead. Oh, there's a 3 in this row. So the 3 in this row makes that a 1 and that a 2. That dislodges this 1 pencil mark and places a 1 down here. The 1 down here makes this a 9 and a 1. This digit I should be able to figure out if I put all of my counting skills to the test. I think this is a 3. This digit, also for the row, I should know, because it can't be a 1, 2, 3, 4, 5, 6, 7, or 9, so it's an 8. These two digits are a 5, a 6, and a 7, so that's the 7, that's the 6, that's the 5, that's the 6. Looking now down these columns, these are just pairs that are left. So I am missing a 2, which has to go there, and now a 3, 4, and I'm missing a 5, which has to go there, making that a 3 and a 5, making that a 3 and a 5, making that a 3, making that a 5 and a 2, making that a 5, making this an 8. And so we've got 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, and a 3. Very nice. Alrighty. So, perfect puzzle to illustrate these style of strategies. Now, if you're doing actual classic Sudokus that are posted, often they'll involve things beyond this. But for most variant puzzles, you really don't need anything beyond the techniques we've talked about here. These are the techniques that usually come up in variants, plus the techniques from the variants that we've been talking about in the other videos. Okay. So, next up, I want to talk about applying this to a few places where all of these techniques apply very straightforwardly, but it's not immediately clear. So here's a slight variant on Sudoku called Sudoku X. And the way Sudoku X works is it's exactly like regular Sudoku, except additionally, you have the digits 1 through 9 on this diagonal and on this diagonal. And I will just say, people call this the positive diagonal and this the negative diagonal. So I will do that, even though I strongly disagree with that claim. But that is the convention, is that this is the positive diagonal because it looks like it's positively sloped, and this is the negative diagonal because it looks like it's negatively sloped. And so that is the usual thing. But effectively, all this does is gives us 2 more houses. So every row, column, and box, but now also every diagonal needs to have the digits 1 through 9. And so we can update and pencil mark things in exactly the same way. And so we can look for a place that seems helpful to start. Like, for example, these cells, I think I can pencil mark. So these cells are... So let's start this time, actually, instead of with that. Let's start this time with asking where 1 goes in places. Maybe that's better. So 1 in this box goes in one of these 2 places. Let's see, 1's down here. I see 3 places. What about 2's? I see right away 2 in this box goes in one of these places. 2 in this box goes in one of these places. 2 in this box goes in one of these places. Okay. So I also see it as interesting to note, where does 2 go on this diagonal? And so I'm going to temporarily corner mark something just to show you how this works. 2 on this diagonal, it can't go in this box because that box has a 2. It can't go in this box because this box has a 2. So one of these 3 cells is a 2. Now, why is that interesting? Well, lots of reasons. where does 2 go on this diagonal? Well, not there and not there. So the 2 on this diagonal is also in one of these cells. Okay. Now, this sort of looks like I've said that 2 goes in one of 5 places in this box, which is literally what the notation means. But if you think about how we got here, actually, there's only one place the 2 could go. Because what would happen if I put the 2 here? What happens if I put the 2 here is I've now ruled 2 off of this diagonal entirely. There's no place for it to go, because as I said, one of these 3 cells has to be a 2, and it can't be if that's a 2. So actually, that cell can't be a 2. That cell can't be a 2 for the same reason. But if I made this cell a 2, the same thing happens. Well, I mean, actually, that one's even worse. If I made that cell a 2, I have the same problem with this diagonal. Now this diagonal just can't have a 2 anywhere, so that can't be a 2. And so this cell is a 2. Okay. Now, if you look at that, you might notice a few other things. Like you might notice that 8 and 9 are similarly situated. So 8 and 9 both sit here with regards to this diagonal. So they both have to go in this box. And so I can corner mark an 8 and 9 on this diagonal into these 2 cells. Those are the only places 8 and 9 can go. But together, these 2 corner marks upgrade. The 2 corner marks upgrade to center marks. Okay. Now, people give that a fancy name too, and you'll find out that Sudoku is full of lots of people giving fancy names to things that probably don't really need fancy names. But people would call this a hidden pair. Namely, if I ask myself the question, where do 8 and 9 go on this diagonal? Collectively, 8 and 9 only go in these 2 cells. And so therefore, these 2 cells have to be 8 and 9. You can center mark them 8 and 9 immediately. It can do exactly the same thing on the other diagonal with 2 and 3. Because 2 and 3 now have to go on this sorry, not 2 and 3. With 1 and 3, we already have the 2. 1 and 3 on the other diagonal have no choices of where to go except for these 2. So we get our 1, 3s. And this is conveniently resolved by these Sudoku of all things. Because that 9 looks up at that cell and makes that an 8 and a 9. That 1 looks down at that cell and makes that a 3 and a 1. Okay. And so that starts to give you some idea as to how really we're doing exactly the same thing that we were doing previously. We just now have additional regions, in quotes, to look at. Okay. So what are these cells? They're not 1, 2, 3. They're 4, 5, 6, 7, and they're not 8 and 9. But these aren't 4, 5 because there's a 4, 5 in the row, which means these are a 6, 7 pair. So these can't be 6 or 7. These are a 4, 5 pair. And that's cool. Okay, so we've got sort of now much more very pencil markable material. But this 2 actually looks up at a 2 pencil mark already. So we can strike out that 2 pencil mark. Means that's a 2. Got all kinds of stuff going on. So now let's fill in these columns and rows. So we need a 1 and a 2. We've got a 3, 4, 5, 6. No, we don't need a 2, sorry. We have a 2, it's in the center. But we do need a 1. We've got a 2, 3. We've got a 4, 5. We got a 6. We need a 7, 8, 9. Okay. Well, these cells are definitely not 7. That one's not 9. That one's not 8. These cells aren't 9. That one's not 8 either. This one's not 1. And so I scan carefully these cells to find the pair / triple that is relevant. And in this case, it is a 1, 7, 8 triple that I have. Or in other words, it's telling me there's only one place I can put the 9, namely there. So I can sort of just get rid of that. This row, I do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9 are these. This one's not a 3 or a 9. This one's not a 1 or a 9. This one can be anything. Maybe it can be anything. There is a 1 in box 8. So this actually also can't be a 1 if you look very closely. Or if you look at these 1 pencil marks, for example. There are many ways to see that this is not a 1. So that's an 8. And whenever you have a triple like this, where you have a triple where everything is down to only 2 options, as soon as you fill in 1 digit, you get them all. So as soon as this is an 8, now this can't be an 8, so it's a 7. This can't be a 7, so this is a 1. And you get all of that more or less for free. That 7 looks down there and makes that a 6 and a 7 while we're at it. This is a pair. Let's see. We've got 1, 2, 3, 4. This is a 5 and an 8, and we know the order actually. And now this is a single for the box. There's only 1 possible option for it, and if you give me enough time, I'll figure out what it is. It's a 3. These are now a pair. We've got 1, 2, 3, 4. I need a 5 and a 6 up here. I don't think a 5 or a 6 looks over there, but I could be wrong. It would be very on brand. Okay, this row. Lots is going on in this row now. I've got 1, 2, 3. I need a 4. I've got a 5. I need a 6 and a 7, and I've got an 8 and a 9. Do I get any eliminations out of any of those things? It looks like very possibly not. What about this row? This row, we need a 1. We've got a 2, 3, 4. We need a 5, 6, 7. I'm going to sneeze 1 second. How do I mute this? Okay. In the process of attempting to mute the mic so that I could sneeze, I no longer feel like I need to sneeze, but if I end up sneezing loudly in a minute, I apologize. Okay, these are not 1. While we're doing things that aren't things, which is my favorite game. This one's not a 5. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what these are. That one's definitely not a 3. Let's see, I'm scanning. And remember, for cells that are on the diagonal, you also should scan the diagonal and ask yourself if the thing could be the thing. And that is very helpful. Okay, so now I'm going to ask myself the question, where does 1 go on this diagonal? So one of these cells has to be a 1. Which one is it? Well, it's not that one, because that one sees a 1 in the row. It's not that one, because I've already pencil marked that cell's not a 1. It's not this one, because this one sees a 1 in the column. Well, these are definitely not 1, because I've filled them in already. It's not that one, because that one sees a 1 in the row. And it's not that one, because that one sees a 1 in the row. And so, in fact, actually, what we have here is a hidden single on the diagonal. Namely, this has to be the 1. There's no other place you can put a 1 on the diagonal. And so, again, the reason why I sort of paired this, no pun intended, paired this with the discussion on Snyder notation is that everything we did for rows and columns and boxes applies equally well to diagonals. Okay. Now, here's another thing that you really should keep an eye on. The remainder of this row is a 5, 6, and 7, but this one can't be a 5. So therefore, one of these 2 cells is the 5 for the row. But that tells us the 5 for the box is in one of these 2 cells. So that cell can't be a 5 anymore. You'll hear lots of different names for that. I generally call it a locked candidate because I think of the 5 in this row is locked into this box. So therefore, nothing else can be a 5. But you'll also hear people call that a pointing something, I think. The pointing nomenclature, I admit, sort of like viscerally doesn't work for me. I can't visualize what people are picturing when they call something a pointing something, because there's not anything pointing at anything. But just however you want to think about it, it's an important deduction to keep in mind that goes with thinking about these things. All right. Let's see. one of these two cells, I'm just looking at my digits again, because I've got lots of digits. So now if I just ask about 1, this digit now is a 1 in this box, and so that makes that a 2 by pencil marks, makes that a 2 by pencil marks. Let's see. And so now the one in this box is down here. And that's almost all of the ones, so that's the last one for that. Okay. So let's fill in some extra digits. So we've got 1, 2, we need a 3, 4, 5, we've got a 6, we need a 7, we've got an 8 and a 9. This one can't be a 4. Careful scanning. None of these are 3. So none of those are 3, so that's very helpful, because as soon as none of those are 3, lots of things happen. So one of them is that now this is the 3 for the row. It's the only place for the 3. So that is a 3. It also means that these cells, if I fill them out, green was a terrible color because I already had something that was green. These cells are now a 4, 5, 6, 7 quadruple. So you can see that, and I realize I'm being slightly obtuse here because I can fill in this digit and all of this will collapse, but I want to point out you can have quadruples on diagonals. And so because this is a 4, 5, 6, 7 quadruple, then you know these two digits aren't 1, 2, 3, 4, 5, 6, 7. These two digits have to be an 8, 9 pair, and you immediately know the order because this can't be an 8, so that's a 9 and that's an 8. But this 4, 5, 7 triple here means that this isn't a 4 or a 7, so it's a 6, meaning that that's now a 4. And now this digit is not a 4. This digit is not a 6, so this is a 5, 7 pair. And so here is the Sudoku X trick. You are about to see the only trick that is unique to Sudoku X, or essentially unique to Sudoku X. It also shows up in Renban, I suppose. And it concerns this cell. Namely, this cell looks at a 5, 7 pair. I don't know which of these cells is a 5 and which of them is a 7, but the orange digits I know are a 5 and a 7, which means that this digit could never be a 7. That's the forwards way of looking at it. The backwards way of looking at it is to imagine, what if this cell was a 7? What would that do? Well, it would make both of these 5s, and that's no good. So I can eliminate 7 from this cell because of this 5, 7 pair. And so that's another common thing that you'll see pop up in Sudoku X. Okay. So now that we have that, we can do that. And now that I've done those examples, I can see that this 5 here gives me a 7 down there, which gives me a 5 there and a 7 there. These aren't 7 anymore. This is a single for the box. We've got 1, 2, 3, 4, 5, 6, 7, 8. This is the 9 for the box. So this is a single for the column. We've got 1, 2, 3. It's a 4, it looks like. So this cell's not 3 or 4 because there's a 4 on the, or sorry, because there's a 3 on the diagonal already. Now there's a 4 on the diagonal, so that can't be 4. So this diagonal is only missing 5, 6, and 7. Except this cell is not a 5 or a 7 by Sudoku, so that's a 6. So that's a 7. That's a 4. That 6 makes that a 5. So that is 6 and a 5. This cell is not a 4, 5, or 6 anymore, so it's a 3. This cell is 2, 3, 4, 5, 6. The cell's a 7. 5 looks down and makes that a 4 and a 5. The 3 and the 8 look at this cell and make it a 9. For this column, what am I missing? 2, 3, a 4 and a 6, it looks like. These are a 4, 6 pair. Sure. It doesn't look like I get a whole lot out of that. That 9 at least goes and removes a 9 from over there, so we could do that. Okay. Let's fill in this digit. That's probably a good idea. Let's do that. So this digit is not 1, 2, 3, 4. It's a 5. So now what's that digit? It's not 1, 2, 3, 4, 5. It looks like it's a 6 to me, which is great because it's going to unwind that 4 and that 6, which is going to unwind that 5 and that 4 out of the center. These two digits are a 6 and an 8, it looks like. So that is an 8 and a 6. That 8 looks down, gives me a 3 and an 8. These two cells, well, one of them's a 3. The 3 had better go up there. 4, 5, 6, and the 7 goes down there. Over here, we've got 1, 2, 3, 4, 5, 6. These are a 7 and an 8 in that order. And these, 1, 2, 3, 4, 5 is there. 6, 7, 8, and a 9 goes there. Okay. So again, all the pencil marking stuff, hidden singles, naked singles, pairs, triples, these all have very relevant implications in Sudoku X, and also Sudoku. Sometimes you'll see only one of the diagonals and not both. It works the same in that case. But the thing I really wanted to highlight here was the, if you have a pair on the diagonal, any cell that sees both cells on the pair, you get to eliminate stuff from. Which is a slightly fancier version of if I've got a 5-7 pair in the row, then I can remove 5 and 7 from every other cell in the row. If I've got a 5-7 pair on the diagonal, I can remove 5 and 7 as candidates from any cell that sees both of them, which is a very useful trick. Again, as I mentioned, that mostly comes up in Sudoku X, but it also comes up in Renbon at the very least. I mean, every once in a while in Arrow, you'll see a version of it, but it is good to know. Alrighty. So, next up, we have this. And so this is an anti-king Sudoku, or as Clover will often call it, a no-touchy Sudoku. So we have all the normal classic rules, but also any cell, no cell that is within a king's move of it can repeat the digit. So because this is a 3, none of these digits are allowed to be a 3. Now, you might rightly point out these digits could never be a 3 anyway, nor could this one. But these two now newly cannot be a 3. So again, all the techniques we've been using so far are going to apply verbatim. But the new thing is just that we can make eliminations in sort of fancy ways. Okay. So I see right away that this puzzle is designed to teach you about the power of anti-king. Because anti-king rule plus Sudoku rules 3 out of everything in the T in this box. These obviously can't be 3. And so what I get actually is I get a 3-corner pencil mark for free out of this. And the same thing happens in every other box. So over here, I get a 4-corner mark. Up here, I get 1-corner marks, which I will write in the wrong digit for, and that will assuredly not cause problems. And over here, I again get my 2-corner marks. Okay. And so lesson 1 about anti-king is that the most powerful cell by far in anti-king is a cell that is in the center of an edge, because it rules stuff out of the most possible places. So we get variations of that. Okay. Now, what am I going to do with that, you might ask, and that would be a very good question. So let's look digit by digit and see if anything exciting pops up. So ones, I see that one of these two cells is a 1. That's not immediately useful. What about 2s? Yes, one of these 2 cells is a 2. 3s, I suspect I know what I'm going to find out. One of those 2 cells is a 3. 4, oh, 4 is different. Is 4 good different or bad different? One of these 2 cells is a 4, is what I get out of that. And let's see, what about up here? Not quite good enough for me to pencil mark. 5s, let's see, we've got lots of 5s. Aha! 5 is placed. So normally, in a normal Sudoku, 5 would go in one of these 2 cells, but 5 can't go here because it's touching a 5. So this is a 5, so we've made progress. Other than making lots of pencil marks, which are progress, technically. Let's see. 5's over here. Oh, interesting. In the central box, 5 is ruled out of all of those, so one of these 2 is a 5. It's not the most useful observation, but sure, I'll make it. I noticed it, so I might as well write it down so I don't have to notice it again. What about 6s? Let's see. Okay, one of these 2's a 6. Let's see. One of those are 6. 6 is placed. 6 is placed here by Sudoku, again, because of the anti-king. 6 isn't in any of those by ordinary Sudoku, and the anti-king rules 6 out of here, so this is now a 6. And now that retroactively places 6 in box 5. It can now only go here because this 6 is ruling out of that cell. And now 6 is in one of these 2 cells. Is 6 the gift that keeps on giving? 6 is going to show up here. If you are interested in looking for X-Wings, you can see that there's a 6 X-Wing there. Let's see, 7. One of these is a 7. Okay, where is 7? Yes, 7 is placed in this box, because it can't go here because of anti-king, so 7 is just placed there, which is then going to place a 7 up here, which is then going to place a 7 over here. Oh boy, and suddenly we've got, I'm going to place a 7 there. That 7 rules 7 out of this cell, which places a 7 here, which places a 6 here, knocks that 6 pencil mark and that 6 pencil mark out, makes that a 6 and that a 6. See, and that's all the 7s, right? I have a tendency to place 8 and digits and not a 9th. Yeah, I'm explicitly told no gas puzzle ever requires an X-Wing, so I'm not doing X-Wings today. I'll probably talk about classic techniques in a later stream. So I'll talk about X-Wings and swordfishes and whatever other nonsenses. Those are probably the main ones. Maybe skyscrapers if I'm really adventurous. Although maybe that's above my pay grade. I'm not quite sure. Let's see. 8s. Let's see. I know one of these 2's an 8. Oops. These 2's an 8. And so that tells me the 8 in this column is here, which rules 8 out of everything except this cell in this box. So if I look at 8 in, let's see, do I want to look at 8 anywhere else? Yeah, 8, I guess, in this box is only in these 2 cells. For what? Oh, not in that one even. Okay, 8 in this box is placed. If I actually look closely, 8 is placed there. Okay, once that 8 is placed, that 8 is placed. And so now I get to do my favorite thing, which is to put 8 corner marks here, but those pair up with the 3 corner marks to upgrade from less useful corner marks to very helpful center marks, which we enjoy. What about 9s? I guess I don't know a whole lot about 9s. I know one of these 2 cells is a 9. That is what I know about 9s. Okay. Oh, 8 is just placed here. which when I place the 8, I'm dislodging a 9 pencil mark, which is going to put a 9 there, which is going to put a 5 there. That 8 is going to give me a 3 and an 8. Those 8s are going to look up the column and give me an 8 there, which is going to give me an 8 there. Got all kinds of Sudoku shenaniganery going on. Is that all the 8s? That appears to be all the 8s. Excellent. Is there more to be done with 9s? Yes, because the 9 is over here in this box. Now, it's a little hard to see, but that 9 actually pairs with the 3, which means that these are a 3-9 pair. That dislodges a 2 pencil mark here, placing a 2, and dislodges a 4 pencil mark here, placing a 4. That 4 comes over here and dislodges a 4 pencil mark, placing a 4. And now this row has only a 2 remaining to place. The 2 has to go there. This row has only a, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Has only a 9 left to place. So that's placed there. This row is missing a 1 and something else. And a 5, it looks like. It looks like a 1 and a 5. We're going to go with 1 and 5. And so we will call that good. Okay. There are now lots of places where we can sort of happily pencil mark things. So in this row, I'm going to go ahead and pencil mark a 1. We've got a 2, 3, pencil mark a 4. We've got a 5, 6, 7, 8, and a 9. So these are 1, 4, and 9. This one's not a 9. This one's not a 4. Let's see. What about these cells? That seems like a good thing to pencil mark. So this box needs a 1, it needs a 2, it needs a 3, it needs a 4, and then it's got a 5, 6, 7, 8, and 9. Okay, well, these are definitely not 4. These are not 1 by anti-king. This one's not 4 by Sudoku. And so that actually means, sorry, it's not 1 either. This is not, or sorry, this is 4 because it's the only place for 4 left in the box. So now one of these two is a 4. This 2 sees this cell, so this isn't a 2, it's a 3. So these aren't 3, they're a 1-2 pair, which means this digit over here is a 3. The digits left in this box are a 1, a 2, 3, 4, 5, 6, 7, 8, and a 9. 1, a 2, and a 9, huh? Yeah, I don't see a lot of good stuff to do with that off the top of my head. What about these cells? These are also a 1, a 2, and a 9 for the row. This one's not a 2 by anti-king. What about this column? This column, I need a 1, I've got a 2, I need a 3, 4, 5, I've got a 6, a 7, and I need an 8. I did too many digits. What did I do? 8. There is an 8 already. There we go. Okay. I was only expecting 4 candidates, and then I had too many. Okay. This is not a 5. Well, that was disappointing. What about these cells? That's a good place to pencil mark. These are a 1, not a 2, 3, 4, and a 5, not a 6, 7, 8, 9. Okay. This one's not a 4 by anti-king. This one's not a 1 or a 5 by ordinary Sudoku, which makes it a 4. So this isn't a 4. So, interestingly, I don't think I can do anything with this. But these two digits I know are a 1-5 pair by anti-king, because they're not the same. So any digit that saw both of these would not be 1 or 5, because these are different. So let's see, what's left in the row? 2, 3, we've got a 4, 5, 6, 7, 8, and a 9 left to go. This one I see is not a 2. This one's not a 2 either. So this one is the 2 by the magic of anti-king. This is not a 2. Let's see. That given 5 is useful because it makes that a 1 and a 5, which makes that a 2 and a 1. That 1 looks over there, makes that a 4. That's not a 4. That 1 makes that a 5 and a 1 and a 9 and a 1. These cells aren't 4 anymore. This cell's also not 1 anymore because of the 1 in the box. So that's a 3. That's a 1. It's a 9 and a 1. That's not a 1. Let's see. What are these two cells? It's not a 4, spoiler. Let's see. I still need a 3. The 3 goes there. 4, and I need a 5. The 5 goes there. Let's see. In this column, I've got 1, 2, 3. I need a 4. In this column, I'm missing a 2, which is going to make that a 9 and a 1 and a 2. That 3 looks down and makes that a 9 and a 3, a 9 and a 3. And then over here, I need a 2, which is going to go there, and a 4, which is going to go there. Excellent. Excellent. So anti-king puzzles are sort of insidious in that the anti-king usually doesn't come up that often, so it usually just lulls you into a false sense of security where you don't quite remember about the anti-king, and then suddenly it does this. If you want, by the way, I am not going to do a disjoint puzzle today, but disjoint also would fall in this bucket of puzzles that you can do where sort of things like pairs and triples are going to do the majority of the work, because it's really just extra Sudoku exclusions is all that really the rule set is doing for you. Okay. Let us continue onward. So I also wanted to do a non-consecutive puzzle. And so what is a non-consecutive puzzle? It's the same rules as normal, except I'm not allowed to put a digit that is consecutive with another digit that it touches. So this digit, for example, could not be a 7. That was a terrible example. This digit could not be a 5 because it touches a 4 and a 6. It's not allowed to do that. Okay. So that is that's really all there is to non-consecutive. So non-consecutive is a genre that generally is more than most purely about spamming center marks. So in a non-consecutive, I will pencil mark 5 cells like this and just say, okay, these are 1, 2, 3, 4, 5, 6, 7, 8. And then go through and eliminate the option. So this can't be a 2. It can't be an 8 because of non-consecutive. These can't be a 1 because there's a 1 in the box. This can't be an 8 or a 2 because of non-consecutive. This can't be a 3 or a 5 because of non-consecutive. This can't be an 8 because of non-consecutive. This can't be a 3 or a 5 because of non-consecutive. And so you can see that just by virtue of having the non-consecutive rule, even if we don't immediately get anything out of it, there's way fewer candidates for all of these things than it looks like there are going to be. Okay, and so let's do the same thing in the other column. So we're here missing a 2. We've got a 3 and a 4. We're missing a 5. We've got a 6. We need a 7. We need an 8. We need a 9. So this one can't be a 2 or a 9 or a 7 for non-consecutive plus Sudoku reasons. These can't be an 8 because there's an 8 in the box. This can't be a 7 or 9 or 5 because all of those are consecutive with 6 or 8. So in fact, actually, this is a naked single 2. So therefore, none of these are 2. Let's see, this one I updated. This one can't be a 5. It's only a 7 or a 9 because of it being consecutive with 4. This can't be a 5 for the same reason. Yep, and so we've got that. Okay, so we're already starting to see some of the power of non-consecutive. So let's pencil mark this row, and then we'll start looking at digits, because there might be interesting things to find about digits. This one also can't be 7, I should note, because it's next to a 6. Okay, so here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 are the things that are left in this row. This can't be a 4 because there's a 4 in the column. It can't be a 5 because 5 is consecutive with 6. It can't be a 9 because there's a 9 in the column, so it is a 3, which means that is a 5. Okay, so this is going to do some damage. This now can't be a 4 because it's next to a 3, so that's a 9 and a 4. This is no longer able to be a 5. This is no longer able to be a 5. Okay, and so we've got a whole row filled in now. Okay. So now that we have all of that, let's look at our digits and where they might live in the Sudoku verse. So I don't think the 1s are necessarily exciting immediately. What about the 2s? Maybe not. Okay, actually, I do see something about 2s. Where does 2 go in this center box? Now, sort of by Sudoku, it goes in any of these places, but because 2's not allowed to touch 3, actually 2 goes in one of these 2 cells, which means 2 goes in one of these 2 cells up here. And so we might get sort of more than we usually would out of Sudoku because of this really strong constraint. So 4 goes in one of these 2 cells. 4 goes in one of these 2 cells. Let's see, 5. There's only one 5, so I'm not super optimistic about 5s. 6s. 6 goes in one of these 2 cells. Is there anything else I can do with 6? Immediately. 7s. 7 is just placed in this box. So 7 needs to go in one of these 3 cells, except not that one or that one. So 7 is here. So 7's in one of these 2 cells. Let's see. Is there any more joy I can get out of 7s? Not yet, I don't think. What about 8s? Oh, I only have one 8, so 8 is going to be hard to get a lot out of. And what about 9s? 9 is placed here just by plain old ordinary Sudoku, which does something awesome. So here's another trick. Where does 9 go in this box? Well, 9 goes in one of these cells. And so here's the sort of the twist, if you will, that you get to do in non-consecutive. If one of these 3 cells is a 9, this cell can never be an 8. Because either this cell itself is a 9, in which case, spoiler, this cell is not an 8, or one of these 2 neighboring cells is a 9, in which case this cell is not an 8. So this cell is never an 8, but that makes it a naked single, which makes it a 9. And that's sort of a variation on how we're using this Snyder notation stuff to keep track of these things in these puzzles. So that 9 looks up there and makes that a 7 and a 5 and an 8. So this is not an 8. I put an 8 there, but I don't think that matters. Okay, what about these cells? Let's just spam center marks again. 1, we need a 2, a 3, and a... Oh, we don't need a 2. Sorry, there's already a 2 in the box. We need a 3, we need a 4, we've got a 5, 6, 7, 8, and we need a 9. Okay, well, these are definitely not 9 because they're next to 8. These are not 4 because they're next to 5. So the 9 I know is over here. Which means that the 9 is in one of these 2 cells. Over here. Oh, I center marked those rather than corner marking them like I meant to. One of these is a 9. Let's look at 9s again. Have to remember 9s aren't anti-king anymore. Okay, so what else are we going to pencil mark now? Let's see. Let's squint at this. You don't see it. Okay. I think I want to pencil mark this column. Which looks ridiculous, but I already know it's going to get me a digit. So again, in a non-consecutive, I'm very happy with to pencil mark rows, columns, and boxes where there's only 4 digits known. So where there's 5 candidates, because so much is going to get wiped out by the non-consecutive. So these are 1, not 2, 3, not 4, 5, 6, not 7, and 8. Okay. This can't be 1 or 3 because it's next to a 2. These can't be 3 because there's a 3 in the box. They can't be 5 because they're next to a 4. These can't be 6 or 8 because they're next to a 7. This one can't be 1. This one can't be 3 because there's a 3 in the row. And so the thing that I saw as I was looking at that was that actually this is the only spot for 3 in the column, because 3 can't go next to a 4 or a 2, and there's a 3 in the row here, so this is the 3. And its location. Now that 3 dislodges a 4 pencil mark, which places a 4 here. That 4 bumps a 4 pencil mark up here. Now, that 4 joins the 7, meaning that these two cells are a 4-7 pair. They upgrade, which dislodges a 9 pencil mark, which places a 9 and a 6 by our pencil marks. That 6 sees this cell, so this cell can't be a 7, so it's a 4 and a 7. And so we get lots of goodies sort of falling in our lap. What are these 2 digits? They are a 2 and a something. 3, 4, 2 and a 5, it looks like. And so the 2 has to go there and the 5 has to go there because the 2 can't go next to a 3. The 2 looks over here at the 1, giving me a 3 and a 2 and an 8. This is not an 8. Let's see. This 5 looks over here, gives me a 1, gives me a 6, means these aren't 6 or 1. Makes that an 8 and a 5, just for good measure. Let's see. Do I have more eliminations I can make based on digits I've placed? Almost assuredly. Where does stuff go in this box? So this box still needs a 1. It still needs a 2. It's got a 3, 4. It needs a 5. It's got a 6. It needs a 7. It's got an 8 and a 9. Okay, so these aren't 2. These aren't 7 by Sudoku. These aren't 5 by Sudoku. Let's see. This isn't 7 by non-consecutive. This isn't 2 by Sudoku. Oh. Well, I should have started there. Because that 2, when I placed this 2, it dislodged a 2 pencil mark, which puts a 2 here, which means this can't be 1, so it's a 7. So that is a thing. Okay, so these are 1, 5. So these aren't 1 in particular. What about these digits? 1, 2, 3, 4, 5, 6, 7, 8, 9. These aren't 9 because they're next to an 8. They aren't 6 by Sudoku either. So they're a 3, 4 pair, which places the 1 and the 9 in the row. This isn't a 9 anymore. So these aren't 3 or 4. They're 6 or 9, but 6 can't go next to 7. So that's a 9 and a 6. Let's see. That placed so many things. 6 in this column can only go in one of these two cells. It can't go there for multiple reasons, actually. Let's see. What about these digits? Let's fill those in. We need a 2. We've got a 3, 4. We need a 5. We need a 6. We've got a 7. We need an 8. Okay. These can't be 5 because they're next to a 4. That one can't be 2. This one can't be 2 by Sudoku. So those are a 6, 8 pair. So these are not 6 or 8. These are 2 or 5. The 5 here tells me the order. So that's a 2 and a 5 and a 1 and a 5. The 5 can't go next to a 6. So that's an 8 and a 6. 1, 2, 3, 4, 5, 6, 7. This is an 8. These remaining digits are a 2, a 3, a 5, and a 9. So these are not 2. These are not 5. These aren't 2 either, actually, because of that 1. This one's not 9 either, so that's actually a 3 and a 9. Uh-oh, I did something badly. What did I do badly? Let's try again. These aren't 2 or 9. So these aren't 3 or 5. This also isn't 2, so that's a 9 and a 2. 2 can't go next to 3, so that's a 5 and a 3. I just mistyped something, I'm sure. I don't know what, actually. So this is a 4 and a 3. That 4 dislodges that 4 pencil mark, places a 4 there. I have a good feeling about us being able to finish this. Okay, what are these? These are a 1 and a 6. These are a 2, 3, 4, 5, 6, 7, 8. 2, 5, and 8. This one's not 2. This one's not 5. Uh-oh, I mistyped again. This one's not 2. This one's not 5. This one's not 8, owing to that 7 there. Oh, I'm kind of shocked that this is not resolved. What are these two digits? These two digits are, let's see, we've got a 1, 2, 3, 4, 5. These are a 6, 6 and an 8 is the answer. Those are resolved, so that's an 8 and a 6. These digits are a 1. Let's see, 2, 3, 4, 5, 6, 7, 8, 9. 1, 3, 7. So this is not a 3, that's not a 7. This isn't a 1 either because it's next to a 2, so this is a 7. So that's not a 7. So this is a 1, 3 pair, but strangely a 1 or a 3 could go in either of these places. These two digits next. Let's see, this row needs a 1. It's got a 2, a 3, a 4. It needs a 5 and a 6. It's got a 7. It needs an 8. Okay, so this is not 1 or 8. This is also not 8 or 5. So where does the 8 go in this row? So in fact, actually, you could see it this way. There's a 1, 6 pair here, which makes this a 5. It makes that an 8 and a 2 and a 5. Whichever way you want to see that. Again, it's always, there's always going to be multiple ways to see the same thing. That 6 looks down and makes that a 1 and a 6 and a 1 and a 3 and a 1. All right. So what's left in this row? 1, 2, 3, 4, 5, 6, 7, and 8. So that's an 8 and a 7. What's left in this row? A 2 and a 3, it looks like. So that's a 3 and a 2. And that gives me a 4 and a 3. And there we go. So that just shows you, again, sort of these, the constraints that only apply, or the constraints like anti-knight, anti-king, non-consecutive, that only apply sort of constraints onto what a digit can be based on what digits are nearby or in the same row, column, or whatever, are very susceptible to just basically pencil mark logic, like we did here. Okay. 2 more puzzles of this sort, and then we will we'll be good. Okay, so this one I had to do for many reasons. So one is it's an anti-knight puzzle, and I wanted to do an anti-knight puzzle. But 2 is that it's called Tilted Windmill. And, well, our supporters around here go by the name of windmills. And so you can see in the chat, if you see, for example, Jay Dyer there has a lovely windmill next to her name. If you want to become a supporter, you can become a supporter by either clicking the join button down below or going to patreon.com/zetamath, depending on whether you'd prefer to give Google money or give Patreon money. And we very much appreciate those of you who support the channel in those ways. And we try to do cool things. So, for example, the supporters get to vote on what puzzle we'll do. And so we'll shortly be doing the most voted on puzzle. So if you want to do that, no obligation, but if you want to do that, you absolutely can. All right. So what is an anti-knight puzzle? So an anti-knight puzzle is a regular old Sudoku puzzle, except that you can't do this whole knight's move thing and get to a digit of the same digit. So this being a 2 means this can't be a 2. And so I think the useful thing to do is to just, for one digit right away, just mark all of the things that it cannot be. So these are all of the cells that are a knight's move away from the 2, and so cannot be 2. Now, of course, you could rightly point out that these couldn't be 2 anyway. But this constraint is famously, we'll say, difficult to scan. But this is also the constraint that I think most wants corner marks. And I think we'll see why as we do the puzzle. Let's start with 1s, because I think this is a useful way to sort of see what's going on. Namely, I can ask, where does 1 go in row 1? It's actually already placed here, because 1 can't go here owing to that 1's anti-knight. And so now I ask about 1s down this column. And so 1 down this column is now placed. It can only go there, owing again to the anti-knight from this 1. And now I look for 1s over here. 1 can only now go here, owing to that 1 by anti-knight. 1 in this column now can only now actually go here, owing to this 1 by anti-knight. And now the last 1 is placed here, and we have all the 1s. I may have lied. We may not in this puzzle, if this puzzle is all going to be singles, we may not actually get to see the cool stuff you can do with corner marks in anti-knight. Where does the 2 go in this box? Only here, because of anti-knight. Where does the 2 go over here? Only here, because of anti-knight. Up here, only here, because of anti-knight. 2 over in this box now, only here because of anti-knight. And the last 2 goes there. Well, how about 3s? In this box, only here because of anti-knight from that 3 and that 3. Oh, gasp, I think there's 2 possibilities in this box. I think... Oh, no, there's not. No, there's not. Sorry. 3 only goes here because of anti-knight in that box. 3 in this box only goes here because of anti-knight. 3 in this box only goes here because of anti-knight. And this is the last 3. 4s. Well, 4 in this box only goes here. 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 4 only goes here. And that's all the 4s. What about 5s? There is only 1 5. So we may, at this point, have to start thinking about things. No, we don't. Where does 5 go in this box? Funnily enough, and this is just anti-knight things, hashtag. 5 in this box is placed, even though that seems completely impossible with only 1 5. But this 5 actually rules 5 out of those by Sudoku and those 2 by anti-knight, so that's a 5. And so now the 5 in this box is in one of these 2 cells. Let's see. Can we do more magic with 5s? I'm going to guess no. Not immediately. about 6s? Can I do a similar trick with 6s? So 6 is going to go here by the same trick that placed the 5. And now 6 in this box is going to go into one of these two cells, but we don't know which one yet. I don't think I know much else yet that I'm willing to pencil mark. 7, we get to do the same trick. The 7's going to go there. And so that's going to tell me that one of these two is a 7. Sorry, not in the center. So 7, I am noticing down in this box, only goes in one of these two places. Which is the kind of thing that looks like it could be useful, but probably is not yet useful. 7 in this box, who knows? What about 8? 8 is going to get placed here, which is going to mean that one of these two is an 8. It's also going to mean that one of these two is an 8. And so now is probably a good time to start center marking things. So let's mark, let's see. Let's mark these. So these are not 1, 2, 3, 4. So these are from 5, 6, 7, 8, 9. Sorry, not 8. There's an 8 in the box. These I know aren't 6, which I guess tells me that one of these two is 6. I did not mark that before. This one's not 7, though. This is 5 or 9. I don't think this sees a 5 or a 9 yet. These cells are not 1, 2, 3, 4, or 5, so these are from 6, 7, 8, 9. These aren't 7. That one's not an 8, fascinatingly enough. These are from, again, 5, 7, 8, 9. So that one's not a 5. Neither of these is an 8. And let's see, here we go. These are from 5, 6, 8, 9. That one's not a 6 or a 5. This is an 8 or a 9. That one's not a 5. What about this box? There's a lot of stuff looking at this box. So I'm actually going to pencil mark this in just to see if anything nice appears. So this cell can't be a 7. I'm looking at stuff this cell sees by anti-night, but it all looks bad. Yeah, let's see. This cell, probably the same thing. This cell can't be... Wait, is there anything? Yeah, the cell can't be an 8 by the row, but doesn't seem to see anything by anti-king. Or sorry, by anti-knight. Anti-knight. I am saying the name of the wrong constraint. That's not going to help. This one can't be a 5. This one can't be a 6. What about this one? Okay, we're getting somewhere. This one can't be a 5 because it sees a 5 here. It can't be a 6 because it sees a 6 there. It can't be a 7 because it sees a 7 there. And it can't be an 8 because it sees an 8 there. So actually, this center cell is a naked single 9. Okay. Now, one thing you might have noticed that might have made you look here sooner, if you've solved a lot of these puzzles, is that this whole grid is incredibly symmetrical. Namely, everything I did for 1, 2, 3, 4, I just did exactly the same for all of them, but rotated by 90 degrees. And then the same thing happened for 5, 6, 7, 8. And so if you think about what that means it's really likely the center cell is going to end up being a 9, because otherwise you're going to completely destroy all of the symmetry. And so a lot of people were sort of inclined to look at this right away, and that's one reason why you might. If you notice there's symmetry, you might look at row 5, column 5. Okay. Now, that does lots of good things, because it means that this is a 7, this is an 8, this is a 5, and this is a 6. And so let's update our pencil marks. Oops, sorry, wrong thing. That's not a 9. Let's see. These aren't 7. That's not a 9. These aren't 8. That's not a 9. Somehow those already weren't 8. I'm suspicious. These aren't 8. Oh, it's 5. Sorry, it was... Ooh, I screwed up my pencil marks there. These aren't 8. These aren't 5 is the thing that these aren't. Okay. So we've got lots of good gooey pencil mark goodness. This 6 looks up and says that's not a 6. Let's see. Do I have more stuff? That 5 looks over and says that's not a 5. This 8 looks down and says that's not an 8. 7 looks over and says that's not a 7. Also says that's not a 7, actually. This 5 also says that's not a 5. This 6 also says that's not a 6. This 8 also says that's not an 8. Okay. So this 7 has ruled a 7 out of this 7 pencil marked cell, so that's a 7. So now these cells are a 6-7 pair, because now I can corner mark 7s into these cells. So these are 6-7. And I know that this one's not a 6, so that's a 7 and a 6, which is going to let me fill in this cell. 3, 4, 5, 6, 7, 8. This is a 9. Let's see. What is left in this column? This 5 sees this 5 pencil mark, which places a 5 here. These digits left over here are a 5, a 6, and a 7, which have to go in that order. So that 7 makes that a 7, which makes that a 9 and an 8. These two digits are an 8 and a 9. Don't think I know the order yet. Oops. An 8 and a 9. This 8-9 and this 8-9 form a pair, making that a 5. Making that a 6 and a 7 and an 8 and a 5. And an 8 and a 9 and an 8 and a 9. This 7 looks up and makes that a 6 and a 9 and a 7. This cell, we've got 1, 2, 3, 4, 5. This is a 6. So that is not a 6. So this is a 6. That 8 looks over at that 8. So that's an 8. These 8s together place an 8 there. These two digits are a 5-9 pair, which ridiculously I think is not resolved yet. Seems implausible, but possibly true. Oh, this cell, I probably should fill in this cell, huh? This is not a 1, 2, 3, 4, 5, 6, 7, 8. This is a 9. Okay, so that's a 9, a 5, and a 9, and a 5, and a 9. And now this cell, 1, 2, 3, 4, is a 5. Woohoo! Alrighty, and so that gives you some sense of how anti-night puzzles work. Generally, I think anti-night puzzle scanning is tricky, and certainly it is an acquired skill, we'll say. But I do think anti-night puzzles, when they're well constructed, are a lot of fun. Alrighty. I have one more, and so this puzzle, this is just a regular classic. So I asked Jovial, who is one of, if not the most preeminent classic setters, if she had anything that would be good for emphasizing the things I wanted to talk about today, and she said, yes, I have one puzzle, it's this one, and it's perfect, so we're going to do this puzzle by Jovial. I know it says Untitled by Unknown, but I know who Unknown is. Unknown is Jovial. So we're going to give this a try. I suspect that this is going to be the harder of the puzzles we have done today, but let's see. Okay, so this is just classic. So let's start with corner marking if we can. Let's see. I see I get some 2 corner marks over there. Aha. I've got some 2 corner marks that instantly pair up on top of my 1 corner marks. So this becomes a 1-2 pair. So that's cool. Let's see. Okay, so I'm going to fill in, because now I have 5 digits in this box. And so now 6, 7, 8, 9 is what's left. But I see this 8 and 9. Look at those 2 cells. So these 2 cells aren't 8 and 9. They're 6, 7. But that now gives me a pair of 6 and 7. So these are not 6, 7. Those are 8 and 9. And by anti-night, this is a... Wait, no, that's the last puzzle. So we've got sort of lots of stuff going on there. Let's look at 3s. One of these 2 digits is a 3. One of these 2 digits is a 3. One of these 18,000 digits is a 3. Let's not do that one. 4. Get a similar trick with 4s. The 4 is placed and becomes a second 4 corner mark, but that means that these 3 4 corner marks get upgraded to 3 4 center marks. Means that I can fill in the rest of the digits here. They are 1, 2, 7, 8, it looks like. But these aren't 2, 7. They are 1, 8. This puzzle is gorgeous already. So these are not 1, 8. These are 2, 7. But that already does some good, because now the 7 looks back over here and makes this a 2, which makes that a 7. That 2 looks up here and makes this a 1 and a 2. The 1 looks down and makes this an 8 and a 9. Makes that an 8. Makes that a 1. And so we've got all kinds of sort of fireworks going off. Not the Sudoku kind of fireworks, the other kind. 1, 2, 3, 4. We've got a 5 and a 7 in this to place here. So that's the 7, that's the 5. In this column, we've got 1, 2, 3, 4, 5. We've got a 6 and a 9 to place in celebration of our 69th stream, I'm sure. So happy 69th stream, everyone. So the 6 and the 9 go in like that. These 2 are a 1 and a 2. And I don't know how that works yet. Let's see. Okay, this row, maybe I want to look at. Do I? Where do I want to look? There's so many places to look. I don't think I've made it past 4 yet in my digit scanning. So let's just quickly scan for 5s. So there's a 5 over here. I don't think that's going to be the key. What about 6s? The 6s are going to join the 5s, which maybe should have been expected given the general theme of the puzzle. So these digits are going to be a 1, not a 2, a 3, a 4, not a 5, 6, 7, 8, and a 9. Let's see. These aren't 9. Oh, am I not going to get a pair this time? This one's not 1. Yeah, maybe I'm not going to get a pair this time. What are these? I guess I should write in. Those are 2, 3, 4. 5, 6, 7, 8, 9. Yeah, these are 3 and 4. So I can write in these cells as 1 and 2, 3, 4, 5. No, not 5. 5, 6, and 7 are gone. 8 and 9. These aren't 8. That one's not 1. That one's not 2. Actually, that one's not 2 either. If I look at the row, fascinating. Okay, so we're gonna have to chase this around a little bit more. So let's fill in. I see what's going to happen here. Let's fill in our 7 corner marks and then our 8 corner marks. And now what that's done to us is it's given us a 7, 8 corner marks that upgrade to a 7, 8 pair. And what that does is it dislodges this 3 corner mark and makes this a 3. And I suspect that's going to be important. Because it's going to make that cell, importantly, not a 3. I mean, maybe it's not important. Who knows? What do I know? I'm just a zeta. Let's fill in this triple. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to give us a digit. So these aren't 5. So that is 5. That 5 looks down here and gives us a 6 and a 5. The 6 looks up there and gives us a 4 and a 6. So that is cool. So this is not a 4. Okay, so these digits... Actually, sorry, let's do these digits first, just to finish the loop. 1, 2, 3, 4, 5, 6. These are 7, 8. And so the rest of the box is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what those are. These are not 9 or 5, so these are a 4, 6 pair. So these aren't 4 or 6, they're 5 and 9. And what's great is that 6 resolves that this is a 4 and a 6, and that 5 resolves that that's a 9 and a 5. So we actually get some immediate resolution of some of the ever-building tension. Let's see. Is there something nice going on here? I know one of these two is a 5. Is there something else that has to go there? Ah, yes, one of them. No, not a 6. Maybe I don't know yet. Oh, sorry. I know one of these two is a 5 by Sudoku, but I also know which one it is, because there's a 5 over there. So this is the 5. So this cell is 1, 3, or 4 by the column, and it's not a 4. So it's 1 or 3. Ah, that's the point. Where does 4 go in this column? This is the locked candidate thing again. 4 in this column only goes in one of these two cells. That is, only goes in box 7. But that means that if I make this cell a 4, I suddenly have removed the ability to put 4 into column 2 at all. So this cell can't be a 4. It must be a 9. Making that a 2, that a 1. These are not a 1. They're an 8, 9 pair. So that's not a 9. Let's see. These are from 1 and 3. 6, 7, 8, and 9. That one's not a 9, so that gives me a 1, 3 pair in the column, which makes that a 9. It gives me a 1, 3 pair in the box, actually. Oh, I guess that's not exciting, because the column is also all done. So the column needs a 2, only 1, 3, and a 4. And I know where the 4 goes. 4 goes there, so the 2 goes there. That 2 looks across and gives us a 1 and a 2. The 1 looks back and gives us a 3 and a 1. And now we've just got some triples to fill in, and then we'll have fully pencil mark the grid. So we've got 1, 2, 3, 4, 5, and get a 6, 8, 9. That one's not a 9, that one's not a 6. That gives me an 8, 9 pair in the column, which is going to be nice. This one's not a 6 either. So that one is the 6, actually. These are a 2, a 3, oops, a 2, a 3, a 5, oh, a 2, a 3, and a 5, that's it. This isn't 3 or 5, so it's a 2. This one's not a 5, so that's a 3 and a 5. 3 gives me a 4 and a 3. And then these are, let's see, a 1, which I might as well just fill in, goes there, because of the ones looking at it. Let's see, we've got a 2, a 3, we need a 4, which goes there, a 5, a 6, and we need a 7, which now has to go here. That 1 goes down and makes that a 3 and a 4 and a 3. That 1 and 3 look at that and make that a 4 and a 1. That 9 looks down there and makes that an 8 and a 9 and an 8 and a 9. That 8 looks up and makes that a 7 and an 8. That 6 looks over and makes that a 7 and a 6, and that 7 looks over and makes that an 8 and a 7. Gorgeous puzzle, Jovi. I loved that. That was a very, very elegant demonstration of all of today's lessons. I enjoyed that one a great deal. Okay, so for those of you who are here for the stream, I'm going to continue streaming after a short break. For those of you who are watching the tutorial video as it's posted later, thank you for watching. Zach also sends his appreciation. Zach would also appreciate it if you would consider subscribing if you haven't subscribed yet. If you'd like the video, if you have not yet liked the video, by clicking the thumb up. And as I mentioned earlier, if you want to support us on Patreon or on YouTube by clicking the join button, or Patreon by going to patreon.com/zetamath, we'd very much appreciate it. Let us know if you like the video, and I'll see you later.